All right, so we're reviewing standard form. And what is standard form? Anybody? Standard form? F of x, yeah, or y equals, okay, go ahead, equals ax squared plus bx plus c. Okay, what's the shape of the graph called that this makes, that U-shaped curve? Makes a parabola. Now, the parent function, the y equals, or f of x equals x squared, that starts at 0, 0, and it builds out from there. 1, 1, 2, 4, negative 1, 1, negative 2, positive 4. Hopefully yours looks a little better than mine. So that's your parent function. Everything's based on that, and you're right, that's called a parabola. What makes these things quadratics? What makes a quadratic a quadratic? Having the x squared or the variable squared, depending on the variable. I'll take having the x squared. That's what gives you that U-shaped curve. When I square 2, I get 4, but when I square negative 2, I also get 4. If it had a degree of 1, then it would be considered linear. So a can't be 0. All right, in standard form, I can't just look at this and know everything. So how do I find my vertex? How do I find the vertex? Obviously, I can't find the vertex because this is generic, but how would I find the vertex? What do I do in standard form? I do find the axis of symmetry. That helps me find the vertex, but how do you find the axis of symmetry? It's so close, but I would mark that wrong. You said negative b over 2a. What's missing, guys? The x equals. And you know I'm really picky about that, right? Because the axis symmetry is that vertical line that cuts through the vertex. So if my graph is over here, that axis of symmetry centers me, and it tells me the x value of my vertex is to the left over here. So the x equals defines it as a vertical line, but the axis symmetry does lead me right to the vertex. So if we're being mathematically technical, this is how you would write the vertex, which can be a little bit overwhelming. And I've shown you this before. The vertex is xy, we know that, but the x value comes from this negative b over 2a. X equals this, we drop it in, and this is f of x, which is the same as what? What's f of x the same as in general? Same as y equals. So this is your x value, this is your y equals, and all this is telling you is whatever you got for x from negative b over 2a, take that number and plug it back in everywhere you see here. The other important thing is that you got to use parentheses because of the power of 2. Okay, this rule is the same for both standard and vertex form. Tell me about the a value. What does a do? There's actually a lot of things a does in controls. Okay, so tell me how you know it goes upward because of a. Okay, so if it's a positive a, your graph goes upward, and it looks like this. And if it's a negative a, your graph goes downward. Now, you know, I was talking about transformations. One transformation would be if your vertex started at 0, 0, and we got a new vertex, you know, from finding our axis symmetry, that would be a transformation. You know, it shifted so many left or right and so many up or down. The other transformation is if a is negative, that changes your original graph that was upward to a downward U. So this negative on its own would be another transformation. All right, what else does a do? We really focused on it before, but we haven't focused on it as much recently. Makes it wider or more narrow. It's that stretch, a vertical or horizontal stretch. So if 0, no, I don't want to say 0. Yeah. Let's say if the absolute value of a is greater than 0, then you're going to have a vertical stretch. Okay, so let's talk about why it's the absolute value. Whether I put a 5 in front or a negative 5, it does not change the stretch. A positive 5 is going to make it go upward, and negative 5 is going to make it go downward, okay? But the 5, not the sign, but the 5 is going to make it grow 5 times as fast up or 5 times as fast going down. So that is going to make it a more narrow graph or make a vertical stretch. So it will look skinnier. So if it helps you, put the term narrow there. Now, what numbers would make it wider? Give me an example, something would make it wider. Say it again. 0.2. 1/5 is the same as 0.2. 1/2, 3/4. Any number between 0 and 1 or 0 and -1 would make it wider. So it shows the absolute value. I'm just going to go, I'm going to do absolute value. I'm just going to go -1 is less than A, which is less than 1. The only thing is A cannot equal 0. Do you understand why A can't be 0? Seems dumb that I even write it, but what if A is 0? What happens to my quadratic? It's no longer quadratic, right? It's linear. So it has to go from -1 to 1, but A can't be 0. Typically, I think they would write it absolute value of A is less than. No, I can't even do that. I have to go between the two, but 0 is less than absolute value of A, which is less than 1. That's how I think they typically write it, but we can do this as long as we say A can't be 0. This is going to be a horizontal stretch or a vertical compression. Horizontal stretch. It's going to make your graph wider because whatever you put in, whatever you're going to get out for Y, you're now taking a half of it or a fifth of it. So you're stunting its growth, so it's not going to grow as quickly. Okay. Another question. How do I find the max or the min? This is the same also for both functions. Oh, I just did that one. How do I find the max or the min? What do you mean the vertex? Okay, located at Y value of vertex. I sort of ran out of room there. The max or min is always on the vertex. So if I know the vertex, whatever the Y value is, that's the highest or lowest point. Okay, I'll know if I have a max and min, or if my graph, or for my graph going upward or downward. If my graph goes upward, do I have a max or a min at the vertex? I have a minimum. So sometimes it's good to have the visual. If my graph is downward, I have a maximum. All right, so that is your standard form. Any questions on that? Anything I didn't cover that you are questioning? Okay, so let's jump to that worksheet I said you're going to do. We are looking at the 5152 review worksheet, and let's jump to the back. Let's put our note card to use here. Got it? So it has the directions, but I have everything laid out here for you. So this is definitely in standard form. Now, I know they don't ask this, but I'm going to help you out. I'm just going to say, hey, A is -1, B is -8, and C is -18. Okay, got it? That helps me. Just looking at this, does my graph open upward or downward? Which way? Downward, because I have a negative. So if my graph is going to open downward, that's a nice reminder. Would that have a max or a min? It's going to have a maximum. Now, I don't know anything else, but I'm going to have to find it. How do I find that axis symmetry to help me with the vertex? What was that formula? Yep, there you go. So get your x equals. Now, it's -b over 2a. If you have a problem with negative signs and you were going to miss and just write -8, put this out front. It's a -8 over 2 times -1. I suggest not trying to type this all in the calculator because some of them will give you the wrong answer because you have to use extra parentheses. So just clean it up. This is 8 over -2. So what does x equal? -4. X equals -4 is my axis symmetry. The vertex is -4. I need to find the y value. So how do I do that? Plug it in. Put your negative on the outside, and then parentheses, -4 squared minus 8. I'm recommending you use parentheses, and you are just going to type that in your calculators. So here I go. Negative and then parentheses. And now you can do this without a calculator, but it is a bit time consuming. You got to watch your signs. So I'm going to type it in, and I got -2. Anybody agree with me? Okay. So that's my axis symmetry at -4. I'm going to draw in my dashed line. I'm recommending you do this dashed line as an anchor, and then you do your -4, -2. Did you catch the axes are counting by halves? Did you see this is counting by halves? So be careful with that. The y value, the max value that I have is at y equals -2. So really important to have the y and the x equals. How am I going to get the rest of this graph though? Like that's not good enough. How do I get the rest of this graph? Yeah, you're right. It's on the back. Number 1 on the back, or number 5 on the back. Okay. All right, well, you have a couple options. One, you could do the extra points. Remember the y-intercept? What do you know about the y-intercept? What do you know about the y-intercept, guys? Always. I can reflect it across here, but how do I find it? Okay, the x value is 0, so I put 0 in. Put 0 and put 0 in, and I get out the c value. Can I graph that on this graph, 0, -18? But you're right, though. If my y-intercept was something I could graph, then I would just reflect it. That's too far off the graph. So how am I going to graph this? I'll make a t-chart. But rather than picking random numbers, you always put your vertex in the middle, and then you build around it with numbers like -5, -6, -3, and -2. If you pick random numbers, you might never get the other side of your parabola. Now, in my calculator, I'm just going to arrow back up, and I'm going to replace that -4 with the -6. Rather than retyping it and having an error, I can do that, and I get -6. Put in my 5, and I get -3. All right, so -6, -6, way down here. Now, I could reflect this. 1, 2, 3, 4 blocks. 1, 2, 3, 4 blocks. I have at -5, -3 here. 1, 2. Or I could throw these other numbers in my calculator and make sure they work. Here is that U-shaped curve called a parabola. Hopefully you can do better than me here. All right, there you go. So did I need all 5 points? No, but at least 2 extra points. Okay, so I'm ready to jump to vertex form. We're not going to spend as much time on vertex form because every rule that I gave you for standard form on the A value and the max and min, that's all true on vertex form. So all of this, I'm going to put a star here, all of this upward, downward, my stretches, my max and min, these are all true on both standard and vertex form. Okay, got it? All right, so other side of a note card or notebook paper, vertex form, what is it? Oh, hold on, you're ahead of me. Okay, you said f of x equals
a times a parentheses x minus h parentheses squared.
Okay, plus k. So there's my power of 2 on this quantity that makes it a quadratic. So in vertex form, I want to leave it like that. You can't distribute the power. You'd have to FOIL it. You can't distribute the a value. You'd have to FOIL it first to deal with the power, then multiplication. We want vertex form. So what do you know about vertex form? I can just look at it and tell you the vertex. What is the vertex in general? It is HK. That is your vertex. And if I know my vertex is HK, then I know my axis is symmetry. It's still x equals, but there's no formula. It's just x equals h. that's going to be that same value. So wherever your graph goes, that axis of symmetry is still cutting through your vertex. Okay, so let's talk about a couple things. When we have this function a times x minus h squared plus k, a tells you if it goes upward or downward. So positive up, negative downward. A also tells you the stretch. So if the absolute value of A is greater than 1, it is going to be a narrow graph or a vertical stretch. If the absolute value of A is between 0 and 1, or between -1 and 1 where it's not 0, then it's going to be wider. Now, the technical terms are stretches: vertical stretch, horizontal stretch. We have that on the front. So I'm going to put a star there. Okay, what's the H do to my graph? What's H? It moves it left or right. So if it's a positive H, it moves it right so many units. You'd give the units. If it's a negative H, it moves it left. Now, make sure you would say right so many units, left so many units. It's always x minus h. So if you have x minus 2 quantity squared, then h is positive 2 and it's going to move right. But if it's x plus 3 quantity squared, that h is actually -3 because it would have been minus a negative. And that would move it left. And again, I'm doing this pretty quick, but you need to be specific. Right 2 units, left 3 units. All right, now, what's the k do? Moves it up or down. So this is really our y equals. So when it's paired with x, it shifts the x left or right, up or down. K is, hey, whatever y was this, now add to it. Y is this, subtract. So this moves it. If it's a positive k, it's going to move it up. If it's a negative k, it's going to move it down. There's no trickery there. That is how you know your vertex, by literally looking at the h and k value and knowing where it goes. That's how you do your transformations. Hey, transformation, it moved right or left. It moved up or down. The a was positive, so that didn't change. But if the a is negative, it's downward. Wide and narrow is also transformation. Okay, questions on this? Jump back to your worksheet then, and let's put this to use real quick. It says sketch the graph of each function, identify all the transformation and the given vertex. I was just going to hit number 1 here. Guys, if you look at this, there's no A, B, and C. There's an A, an H, and a K. So the A value is what? A value is 2, isn't it? Positive 2. So we're going to have an upward U, upward parabola. The H value is what? Is it 1 or -1? Well, here's my formula, bless you. It's A and then x minus h quantity squared. Should be x minus, shouldn't it? So is the h value positive or -1? -1. Why? Because I could rewrite it as x minus and it'd have to be a -1 squared plus 1. So the h value is -1. That means the transformation there is going to go left 1 unit. That's what I'm talking about. The transformation is not just left or right, it's how far. Okay, what's the k value? Just a positive 1. So that does what? Moves it up 1 unit. So what's my vertex? If we took the parent function at 0, 0, we went left 1 and up 1. What's my vertex? -1, positive 1. I know it doesn't ask this, but what's the axis of symmetry? You don't have to do any work. What is it? X equals, right? X equals -1. So I would have that dashed line coming here. I know it doesn't ask this, but what is the max or min? Does it have a max or does it have a min? The graph's going to open upward, right? So I agree with the minimum. What is the minimum? You don't even have to have a graph to know the minimum. The minimum comes from the y value of the vertex. So the minimum value is y equals 1. Okay, now how am I going to graph? Oh, there's one more transformation. The A value is 2. What's that do to the graph? It's going to be a vertical stretch. I would take the word narrower, but it's going to be a vertical stretch. If it was a negative, then we'd have an extra that would say downward. All right, in order to graph this, I'm going to put that vertex in the middle again, and then pick some points above and below it. 0 and 1. So when I go to do this, you know how we put the 0 in, and a lot of times we don't get out 1, we put the 0. When we put the 0 in, we're going to get something different out because it's going to be 2 times 1 squared plus 1. So you could do that in your head. You can throw it in the calculator. 2 parentheses. I'm just going to go in with -3 plus 1, close them, square it, plus 1. So I got out 9, and that is on my graph. So -3, 9. And if I want to, I can reflect that, and I could just sketch my graph in now, but I'm going to go ahead and put the next number in just to get a better graph. And I got out +3. Can't get in there. All right, so what am I at? -2, +3, and then I can reflect that. There is my narrower U-shaped curve. There you go. Again, you could throw the other points in. If we put 0 in, we'll get out 3. And if we put 1 in, we will get out 9. Okay, so a lot of information from a little equation.